Alrighty, so today we're just going to take some time summarizing factoring. Okay, so we've learned a lot of different methods, and so we're going to look at problems that kind of incorporate all of them and figuring out, hey, when should I use which strategy? Okay, and so the first thing we learned was how to factor out GCFs, right? And so this is always going to be the first thing we look for. No matter what the problem, you should always be checking for a GCF, because if there is a GCF, yes, you can factor it without factoring out the GCF, but factoring out the GCF first will always make it easier, right? And when we're asked to completely factor something, if we forget to leave out a GCF, we technically haven't factored it completely. Okay, so we're going to factor out the GCF, and sometimes when we have 4 terms, we can use grouping. That's where we would split up 2 terms and 2 terms and find the GCF of each. Okay, that came into play in our most recent lesson, right? Now, the second thing we're going to check for after our GCF is our special products. And these are our perfect squares and difference of squares. Okay, so when we say special products, if we see a special product, we can factor it super quickly, right? And so these are our perfect squares, which are a plus or minus b squared, right? Which is a squared plus minus 2ab plus b squared, and our difference of squares are a plus b, a minus b, which is a squared minus b squared, right? So if we can recognize, hey, if I see this pattern or I see this pattern, I know that I can factor them out like so, okay? Now, if we have checked for a GCF and factored it out or not, and we don't have a special product, but looking at standard form, if we have a leading coefficient of 1, if that a value is equal to 1, right, then we can go ahead and move forward with the product and sum, right, where we take the product, we can figure out, hey, I want a product of C and a sum of B, okay? And then lastly, if we have a leading coefficient that is not 1, right, where we have a coefficient here for a that isn't equal to 1, then we would do a times C, right, and then find the product of a times c and the sum of b and factor by grouping, okay? So let's just do a couple examples, and then we'll call it a day, okay? So 5x cubed minus 10x squared minus 40x. So the first thing we're going to do is check for that GCF, right? We do, in fact, have a GCF here. Our GCF is going to be 5x. So if I factor out the 5x, I get x squared minus 2x minus 8. Okay, and so then we go down the line, right? This is not going to be a perfect square, right? Because the 8 is not a perfect square. And we have a leading coefficient of 1, so we're doing a product of C of negative 8 and a sum of negative 2, right? So we know that this is going to boil down to this kind of product, right? So the two numbers that are going to give us a product of negative 8, a product of negative 8, and a sum of negative 2 are negative 4 and 2, right? Because negative 8 is negative 4 times 2. And so we get x minus 4, x plus 2, and then we're done. All right, not too bad. Cool. Number 2, we'll do this in blue. Let's check for a GCF first. We find a GCF of 2x. So when I factor out that 2x, we get a 9x squared minus 49, and the resulting polynomial is a special product, right? We have a perfect square minus another perfect square, so this is a difference of squares, right? And so this 9x squared minus 49 is going to factor to a plus b, a minus b, in this case 3x plus 7, 3x minus 7, and don't forget that GCF, okay? So there is our completely factored form right there, okay? And so it's just kind of going down the line really and seeing kind of how can I break up these polynomials. All right, so 3. If we look at 3, we have a leading coefficient that isn't 1, so we can jump into a times c, right? But we do have a GCF here as well, right? Our GCF is 4. So I'm going to factor out the 4 first. We get 3n squared. I want to do this in red, actually. Let's do green. 3n squared as, or sorry, 4 3n squared minus 7n minus 6. There we go. Okay. Now, because we're kind of at this, right? Product of a times c and sum of b, right? So a times c, we want a product of negative 18 and a sum of negative 7. So those two numbers are going to be negative 9 times 2 is negative 18. Negative 9 plus 2 is negative 7. So remember, we take this pair, right, this information, and use that to rewrite this trinomial as a polynomial of 4 terms that we can factor by grouping. And so this is going to become 3n squared minus 9n plus 2n minus 6. So we took that negative 7n and rewrote it as the sum of those two terms, okay? Of these two terms. This allows us to utilize grouping, right? Factoring by grouping to factor this out. So the first two have a GCF of 3n. I'm left with n minus 3. My second two terms, 2n and negative 6, have a GCF of 2. I'm also left with an n minus 3. And remember, grouping, we always want to end up here, right, where we have a common binomial factor. And so once we factor out that by n minus 3, we get 3n plus 2 remaining. But we cannot forget our GCF from the very beginning, right? And so this is our fully factored form, right? So just don't forget the GCF. If you factor out GCF, make sure it's always included in your answer, okay? I'm going to box these as well. All right. Actually, I'm gonna stop it here. Okay, I'm gonna have you guys do these three on your own. I'll make sure to include the key with the notes, okay? And then I'll have some additional practice put up on the website as well, okay? So just looking forward, we've actually wrapped up this unit, and so we'll just be reviewing the rest of the week, and then we'll have some sort of assessment next week.